fusion, every day you wake up in the morning, you're essentially living under a giant fusion reactor, which is the sun. And we've been trying for decades to harness the sun. But what if we can actually artificially create a sun on Earth in a bottle? But we'll talk about that later. This section is supposed to be about solar.
My name is Casey Hanmer. I'm the founder and CEO of Terraform Industries. We're making cheap synthetic natural gas from sunlight and air. Solar is a pretty neat trick. The art of a useful energy conversion is to take energy somewhere where it's cheap or not needed and convert it to something where it's expensive and needed. And you can extract value by doing this and pay for the process and pay for yourself and take home a tidy profit.
Solar is nuclear fusion with gravitational confinement and solid state conversion. You don't need a steam turbine to convert it to energy into electricity. And so that's amazing.
The advantage of solar energy is that the sun is a maintenance-free, long-term commitment, inexhaustible nuclear fusion reactor. It's just 8.5 light minutes away. It's in our local neighborhood, comes up every morning. Essentially, free energy rains down on our heads all the time. And by free energy, I mean about 1 kilowatt per square meter, which is a lot. The form of solar energy that's super exciting to me, however, is solar photovoltaic power. Solar photovoltaic power takes our increasing wizardry with silicon and allows us to use that to directly convert the photons that come from the sun, bang into the silicon, kick some electrons across a diode junction, and then the electrons are like, oh no, I'm out of equilibrium, I want to go back to the other side. And you say, no, you can't do it, it's a diode, so they have to go a long way around through your wire, and you get energy out of that. And the amazing thing about a solar photovoltaic panel is that it's 20 to 30% efficient, which is almost as efficient as a heat engine, as a steam engine, but it has no moving parts. It costs almost nothing. Last year, I heard that we deployed about 600 gigawatts worldwide, which is more than the total global nuclear fleet in 1 year, which is it's a lot.
I think solar, we've seen it in the data. It's the amount of what we can achieve now in terms of cost per output has been phenomenal. That learning curve has been absolutely phenomenal. It continues on. So I think there's no question that solar is going to be a huge part of our energy future.
It allows you to take unproductive land, put essentially what rounds to a pane of glass on it, and then it will spit out energy approximately forever at low cost. They're literally machines that you put on the ground and they spit out wealth. So now you have extremely high quality energy because you can easily convert it into other forms. But it's in the form of direct current power, and it's out in the middle of a field somewhere. You still have to get it to the market. You still have to get it to the person with a credit card and make a Stripe payment for the electricity because that's where it's generating the value. You have to get it from where it's produced to where it's needed. And the way this has been done traditionally is you put it into power lines and then move the power lines down the road to people. And along those power lines, you can put some batteries in various places to even out the load and make sure you have power available in the evening and at night. You can allow the price to swing a little bit so that the battery operators make some money and so that you are able to use price signals to accurately predict how much demand there actually is and how much you should actually build. It's very straightforward. It's completely uncontroversial. There are multiple island nations right now that use solar plus batteries and basically nothing else for power. And it's actually as reliable, if not more reliable, than conventional, gas turbine power plant or a diesel power plant or something like that.
Well, solar has gotten cheap because it's a solid state technology. There's no moving parts. It's pretty simple from a mechanical standpoint. That quality is very associated with falling prices and pretty good learning rates. And as you just increase deployment of solar, the cost of making the panels has come down and come down.
The really incredible thing about solar, though, is that you kind of have a choice. When you put in a solar plant and you hook up some batteries, you get to choose how many batteries you attach, and that allows you to decide how much power you're going to have. The batteries add cost, but they also allow you to use the power more. In concert with that, you basically want to have a level of economic productivity of your end use. And this ends up bifurcating. It's a foregone conclusion that solar is going to get extremely cheap in the future. If you can use that power in the field, right next to the solar array, you can get power that's insanely cheap, well under $10 a megawatt hour. And this is transformational for processes that use electric power to perform fundamental chemical conversions or interconversions in matter. We're talking materials processes. These are the processes that right now emit an incredible amount of CO2. The industries that produce most of the CO2 and solar revenue, you could never have hoped to decarbonize them by paying $100 a ton to decarbonize, right? The only option here is to say, well, humans obviously need a lot of concrete. They obviously need a lot of steel. They need a lot of these other kind of materials. These materials are extremely energy intensive to produce, which means that we basically use coal to produce them. They're very polluting. Let's figure out a way to take cheap solar, which is way cheaper than coal if you can use it as it is, and then this demand and say, can we use this cheap solar to give people this fundamental necessity at a better price than they could ever achieve with coal with a low capex process? That's the $1 million question.
I think there are some questions as to how much energy do we want in the end and how much square footage will those panels take up? Are there limits to how much we want to sort of cover the earth with solar panels? And that's a human question, right? That's an aesthetic question. My hope is that we just continue to get more and more efficient with our panels so that you just need less of, again, that square footage question. But no question that will come down in cost. I think batteries, same thing. And they're such a great pairing, the solar and batteries together. So we'll see a lot of electrification come through that as well.